Introduction to Heap. In this, we'll be covering following topics. What is heap? Types of heap, construction of heap, properties of heap, and Heapify function. With what is heap? Heap is a binary tree based data structure, but it should be a complete binary tree. Now, what is a complete binary tree? A complete binary tree is a binary tree in which all the levels are completely filled, except probably the lowest one, which is filled from the left. Now we have two trees image there. We can see the one image in the left side is a heap. Now let's start with types of heap. There are two types of heap, max heap and the min heap. In the first image, it's a picture of a max heap. Now we can see all the parent nodes are greater than the child nodes in the max heap. That is, the first node value is 10. Second and third node have the value 9 and 4. So the root node is greater than the child nodes. And when we talk about min heap, the root node has smaller value than its child node. That is, the parent node is always smaller than its child node. We can see in the image there. Now let's start with construction of heap. In the image we can see there are several steps. In the step 1 we have one value, that is 45. Step 2, we have added the value in the left side of the parent node. Then step 3, we have added the value in the right side of the node. But we can see that the 54 is greater than 45. But as it's a max heap, the greater value should be the value of the parent. So we have swapped the value of 45 and 54 in the step 4. And this is how we construct a heap. By satisfying the property of a heap at each node. Now let's start with the properties of heap. There are mainly three properties of heap, but we'll take one example to understand it. We have taken I equal to 2. That means the node at the second index, that is 9. So to know the left child of that particular node, we multiply the index to 2, that is 2 into I. So the left child of that node is the node at the fourth index. So we got the node as 7. Same, to get the right child we have one formula, and to get the parent child we have the formula. So these are the three formulas to calculate left child, right child, and the parent node of a particular index node. Let's talk about Heapify function. This is one of the main important topic of heap. This function takes the current node and convert the tree below it to a heap. Let's take one example. In the scenario second, the child node value is greater than the parent node value. So what we did, we swapped that two nodes. That is, we swapped 2 and 7 to make it as a max heap. So this is how Heapify function works. To understand Heapify function better, let's take one more example. At the step 1, we can see the 2 is smaller than 10 and 9 both. But it's a max heap, so what we did, we swapped 10 with 2. Then again in the step 3 we can see that 2 is smaller than 6 and 5. So again we have to swap it. Why we only swapped with 6? Because we check from both the child node which one is greater. We swap with the greater one. So 6 is greater here. So